Hello and welcome to Essentials, the series where I cover some fundamental skills for bug bounty hunters which lie outside the realm of hacking. And in today's episode, I want to cover really the most fundamental skill for a bug bounty hunter, which is reading HTML. So, HTML is essentially the building block for websites, and it's how developers program them. And we as bug bounty hunters tend to spend a lot of time hacking on the web, so understanding HTML is really important. And to showcase you some of the features of HTML, I've prepared a little demo here to show us how HTML looks like and how developers program in HTML. So the first thing you can see is that HTML is laid out in a kind of like a tree-like structure, where if you see here, each tag, as it's called, has a tag above it, and the tags below kind of show like a relationship. So this H1 is inside this div, which is why there's an indentation here. And inside the tags, we can also add attributes, like this class attribute here. And these can kind of be used to provide information to the tag. So this class attribute is used to style the tag. It's used to indicate that this tag uses this styling. So it's sort of like its design, for example. And HTML is run by the browser, which is what we navigate through the internet with. And browsers do some interesting things with HTML sometimes, which is worth knowing as a bug bounty hunter. For example, a lot of browsers will actually correct tags. So if this allows me to run this, which it might not, we'll see. Yeah, see the browser, even though I didn't close that HTML tag properly because it needs to have the slash, the browser actually still rendered it correctly. If I look at the source code here, the browser corrected this tag, and that can be used sometimes. Am I looking at the right one? Yeah, so that can be used sometimes to bypass some kind of validation if you're trying to inject HTML and a web application firewall, for example, is blocking that. So now I want to actually cover some of the important HTML tags for us bug bounty hunters. And I want to start off with the script tag. And the script tag is important because it's how we actually write JavaScript into websites. And JavaScript is what makes websites tick, it's what makes them function. So if I wanted to program in a button that takes you to a different page, I could do that with JavaScript. So as a bug bounty hunter, you might find that your input is getting reflected into the script tag. And if you can get out of that input, if you can, for example, put like, I'll show you. If you can, for example, like get injected into like a function like this, and you can, for example, escape that by putting a quote in, and then you can write some kind of JavaScript like this, you could get something called cross-site scripting, which is where you're able to execute JavaScript on a victim's browser. And the reason that's important is because then you can perform actions on behalf of that victim. You can send requests. For example, if this was like a bank platform, you could send a request to transfer money to your account. So that's why cross-site scripting is considered a vulnerability. And if you are able to get input here, you might be able to escape it. So that is one tag you can be aware of. And the next tag I want to talk about is this link tag, indicated by an A here. And what the link tag does is it takes us to a different URL. And if you see it like this, where it's just one slash and it's written like that, that means it's going to take us to a URL on the same website. So hopefully if I reload this, oh, yeah, it'll take me to a URL using the same website that we were on before. But it can also just be a normal protocol. So if we say like google.com and we save that there, for God's sakes, then if we go back here, it will redirect us to a different homepage, which is google.com, of course. So that's two ways you can use it there. Now, there is a weird quirk with this tag, and it's something that a lot of bug bounty hunters know. But if you don't know, it's that you can actually run JavaScript from this ref tag, which is a bit weird. Like, there's a protocol that looks kind of similar to the HTTP protocol. It looks like this, and browsers for some reason, I'll just get rid of this because it annoys me. And browsers for some reason execute this as JavaScript. I've never actually seen this used before. It seems like a very weird thing to do, but if I click on that, you see it'll just execute JavaScript. But that is quite interesting because if you are able to inject your own input into this ref attribute here, and that input is like, for example, reflected here in a query parameter. So if it was like something like this, like URL is equal to like test or something like that, and that input there went here, then you could also look for a cross-site scripting attack that way. Although in 2025 a lot of developers are aware of this now, but maybe through a more advanced cross-site scripting attack you could get this payload to fire. And the next tag here we have is the image tag. So pretty self-explanatory. The image tag renders an image here from a website, as we can see here. Obviously this isn't an image, so we just rendered a kind of like a broken image there. But what it basically does, and this is kind of interesting to me, is that when you go onto the web page, it actually sends a GET request to whatever URL you have here, right? So if we sort of refresh the page here, you'll see that there'll be a GET request sent to, maybe not, hold on. Yeah, okay. So as you can see here, the image tag sent a GET request to example.com, and it attempted to fetch this image so that the browser could display here. But obviously that's not an image, so it's not going to display anything. But an image tag could be used to send a GET request on the same domain. So if you're able to inject HTML and you can send a GET request, if you're able to inject HTML, then you're able to make the victim send a GET request to somewhere on your website, which could be useful if, for example, this was a website that you controlled and you wanted to exfiltrate data. So for example, if I was like, this was like attacker.com and I had like the image tag here was like an API key that the user was using, then the image tag would send a GET request to my website, and then I could just read the logs and find out what this API key is. So it could be useful that way. It saves you having to like write like a fetch request using a script, which a web application firewall might block. So that is a way to bypass that. And then while we're on that topic as well, then I want to talk about another way you can execute JavaScript by adding an attribute to a HTML tag. So you have sort of these I think they're called HTML events, which fire when something like the user does something. So for example, if the user clicks this image here, then we can execute JavaScript. And with these events, you don't have to put like this thing here. Like with the ref tag, you can just put JavaScript here directly. So if I put alert there, and I once again refresh the page and I click that image there. So right, sorry about that. I had my proxy on and I forgot to turn it off, and I was wondering why the website wasn't loading in. And then I checked Kaido and all the requests just got stopped, which is a bit annoying. So anyway, I was talking about these HTML events. So as I was saying, these directly execute JavaScript on the browser. So if I now reload the page like that and I click the image, you can see that the JavaScript was executed. So if you are able to inject attributes into an HTML tag, you could try using these I think that's actually called like DOM events or something, and basically they allow you to also execute JavaScript, which could lead you to that juicy cross-site scripting attack that we all love and want. So That's it for the image tag, and we can now move on to the iframe tag, which is a very interesting tag itself. And the iframe tag allows us to load up a web page on another web page. So it basically creates like a small box there here, as you can see, and it loads up this website, and we can now see it here. We can actually interact with them. We can even click buttons here, and you can see. Right, that's not functional, but we can like click buttons and stuff. We can actually use the web page like completely normally, as if it was like on our browser. So that is a very interesting feature, and it has a lot of quirks to it. And the main thing is that, like, if we look here, right, the browser will actually not allow us to execute JavaScript inside this iframe. Because if you think about it, right, if you went on like an attacker's website, imagine this is like some hacker's website, and he coerced you to click on it. If you could just execute JavaScript like the way we were executing it here on this website, then he could just open up like your bank page, and you could just execute JavaScript there and just like transfer all your money to his account because he can run JavaScript there. So to stop that, browsers decided that this is no longer allowed, and they implemented something called the single origin policy, which is quite complicated, and I'll make a video about it soon. But it basically prevents us from simply executing JavaScript on this iframe. But you can't get an easy vulnerability like that, unfortunately, anymore. But the iframe tag loads up here from a source, and there's a lot of sort of JavaScript stuff to do with these iframes, because since we can't execute JavaScript directly, we have to communicate with the iframe using something called post message, which is something that I will also make a video about soon. But it is a very interesting topic, so if you want to read more about it, you can. And it's also where a lot of vulnerabilities are happening now, because it's some sort of it works well with attacking third parties and supply chains. A lot of websites integrate with each other now, so like developers might put in like an iframe from like a third party website, like an ID verification thing or something, and they will generally use post message to communicate with them. So if you can find a vulnerability in that third party, then you can probably tie it back to the main website. And that is basically it for the common HTML tags. Now I just quickly want to run over one more thing to do with HTML, which is React.js. And React.js is a UI library which is used by pretty much like every website nowadays. And basically what it is that basically instead of writing like pure HTML, what React.js allows you to do is write in this JSX file format, which means that we can write both JavaScript and HTML in the same file. And then we can also create our own HTML components called, very descriptively, React components. In normal HTML, it's actually impossible to create your own tags. Tags are set, and something you can do about that. But in React, you actually can make your own components. And the way it basically works is, if you see this test component here, right? I've created that in another file, and test component is made up of different HTML tags. So it's kind of like saving like a module and then reusing it a few more times, right? And the same way that the HTML, normal HTML tags had their own like attributes here, we can also add attributes to our components. Like I could say like on is equal to false, and we could like program that stuff in there. So it's a very useful library for developers, and it's actually starting to get used by pretty much every single website out there. There's not a lot of vulnerabilities associated with it. It's actually a very safe framework, but actually I'll show it to you here. Or oh, oh, there you go. There you go. There's React.js, and this component you can see is running here. So there's not a lot of vulnerabilities associated with it. It's a very safe library. because it doesn't actually execute templates during runtime. It actually compiles everything into JavaScript. What does that mean? Well, these templates, you can see these in brackets, are raw JavaScript code. They're kind of like, if I, for example, put myself a bit of JavaScript here, and I said demo is equal to a test string here, and then instead of saying React here, I can actually say demo. And if I load it automatically, you can see it replaced it with test the same way as I have here. So if you might think how this could be a vulnerability. If I could inject like an input field and put these two brackets in, and then put some kind of JavaScript in there, would that execute? Well, thankfully not, because React.js actually doesn't allow that. It only allows templates that have been created before runtime, as opposed to something like Angular.js, which does actually allow creating templates at runtime, and that had a lot of vulnerabilities. So it makes sense why a lot of developers switch to React instead of using frameworks like Angular. So if you enjoyed this video, please be sure to subscribe to the channel and leave a like. And I also encourage you to watch the previous episode on prompt injection. It's very interesting, and it details exactly how hackers are actually attacking LLM chatbots in websites to get more vulnerabilities and to try and leak user data. And as always, thank you for watching and happy hunting.